Okay, so here are a few examples from homework for section 1.6 that if you got stuck on, you can kind of watch me walk through them. Hopefully this makes sense and helps out anything you might have struggled with in class. So the whole point of this is we're finding asymptotes, and we're defining limits that way as being part of asymptotes. So the first thing is to figure out where would these possible things occur. But really to do that you have to think of the domain, because if it's a vertical asymptote, it's gonna be something where it goes up along it towards this way or down this way towards it. And then for horizontal, it's going to go as you go towards infinity and towards negative infinity. Okay. So for this first one, let's find the domain before we do anything. Now there's two issues we have here going on this one problem. This is 22b. One is that this guy can't be 0 in the denominator, because if it is, it's something over 0. And this inside has to be greater than 0 as well, because if I have a negative in there, it would be undefined, or yeah, also undefined. So really, the whole domain is where 4 minus x squared is greater than 0. So I have to solve this. And these it is 2 plus x, 2 minus x is greater than 0. That tells us we're looking at points between negative 2 and 2. And when I plug numbers in and check around that, I get negatives out in the outside, positive in the inside. And all I do is just pick numbers like left to negative 2 and did it in my head real quick. And this ends up becoming um, negative times a positive, so it's negative. This becomes positive times a positive, which makes it positive. And this becomes positive times a negative, which makes it negative. So I know then my domain for this function is that x has got to be between negative 2, negative 2 and 2. So what that also means is there are no horizontal asymptotes, because I can't limit out towards infinity and negative infinity. So there's not a whole lot to do. All I really have to do is check to see, do I have vertical asymptotes? And the tricky thing about that is I'm continuous between negative 2 and 2 except for those two values. So what I actually have to do is I have to do the limit as x approaches 2 from the left of x over square root of 4 minus x squared, and the limit, oops, out of space here, as x approaches negative 2 from the right, actually, for x over square root of 4 minus x squared. Now, on the top, this is continuous, so really when I'm going towards 2 from the left, it's just 2. Okay. Oh, and if you're wondering why I picked 2 from the left, let's look at, if I look at the graph here, sorry, I probably should explain that too. I'm at negative 2, between negative 2 and positive 2. That's where I'm like fitting the graph in somewhere in the middle here. And I know what this looks like because I already looked it up on the computer beforehand. We'll look at it in a second together when I get done with the limits, because I want to do this like without having graphed it. But there's stuff going on in here. So the question is, do I limit as I come to 2 from the left or from negative 2 from the right? So that's what I'm looking for. So that's why I'm doing 2 from the left and negative 2 from the right. Now, in order to do the next part here, I know the denominator is going to go towards 0. But I want to be able to think about this in terms of like positive 0 or that negative 0 we talked about in class. It's not really proper notation, but it's a better idea. So if I plug in a number close to 2 from the right, I actually don't even have to do much with it. I know from the table I did up here, oh, it's going to be positive down here as it gets close to 0. So this is that quote unquote positive 0. So I have 2 over a really small positive number. This guy's going to go to infinity. Now from negative 2 from the left, the top will go towards negative 2, and the bottom, again, if I go to factor this out, 2 plus x, 2 minus x, and I'm sorry it's sloppy, but just I write sloppily. I'm still going towards 0 because I'm coming towards negative 2 from the right, so it's going to be 0, but again, it'll be that positive, quote-unquote, positive 0. So negative over a positive number that's tiny, negative infinity. So I do have vertical asymptotes. X equals 2 and negative 2, because I'm approaching negative and positive infinity as I look at the graph. Horizontal asymptotes, none. And that's because I'm never going to level off towards positive infinity or negative infinity. Now, if I look at that problem on the computer, y equals x divided by 4 minus x squared to the 1/2 this is what we see. And here are the two lines, and I'll make them dashed. Object properties, style, let's do dashed lines like that. Style. Okay, so you can see the graph goes up towards positive infinity, coming in from the left towards positive 2, coming to from the right for negative 2. It goes towards negative infinity, and again they have these two vertical asymptotes that cover it in there. And it doesn't have a horizontal asymptote anywhere because of the fact that it doesn't exist enough to go towards positive infinity or negative infinity. All right, next example I want to take a look at is number 24. Number 24, same thing. The first thing you have to look for is domain to look for the vertical and horizontal asymptotes. The domain, let x squared plus x minus 2 equals 0. That's x plus 2 times x minus 1. It gives me then positive 1 and negative 2. Now, what'll make this easier I'm going to check out the limit, I guess I should say. I have to do like actually 4 limits technically. I need to do the limit as x approaches 1 from the right, limit as x approaches 1 from the left, limit as x approaches negative 2 from the right, and limit as x approaches negative 2 from the left. I need to do those 4 limits to figure out if I have anything going towards infinity, like infinity from the right or left, or negative infinity or something like that. But what'll make this easier is, again, I know that this guy's going to be approaching 0 on the bottom for all 4 of those values. So the question really is this a positive or negative 0 we're approaching? So at negative 2 and positive 1, those are our zeros that we're approaching. So the question is, from the left and right, is it positive or negative? So again, pick a number left of negative 2. Like negative 5, that's going to be negative times negative, positive. Between negative 2 and 1, like a number like 0, it's positive times negative, it's negative. Number right of 1, number like 7, positive and positive, product is positive. So I know from the left and right, even though these are approaching 0, this is approaching 0, it's a positive 0, this is a negative 0, negative 0, positive 0, coming at those directions. So this is from the right, from the left, from the right, from the left. Now on the top then, I can really just kind of plug those numbers in. So 1 minus 1, oh, this has a little twist to it that we have to discuss. I didn't catch this until just now. I should pay attention to the problem more. On the top, I have 1 minus x. That guy is the same thing as negative x plus 1, which if I take out the negative, that gives us x minus 1. That's going to cancel with that actually. Very interesting. I didn't catch that. So hopefully you did if you're coming to check your work. So really what that means is at 1, I don't have to check out anything on this graph because this is actually not what we're going to see. That's what we'd see in the denominator, but I don't have to worry about it because this is a point discontinuity. And the reason I know that's a point discontinuity is because it cancels off. What I'm really looking at then is really negative 1 over x plus 2. And so what I have to really look for is not these two values, but from the left and right of negative 2. Okay, wow. So we have negative 1 over x plus 2. Well, if I take a number close to negative 2 from the right, that means I'm actually talking about a little bigger than negative 2. I'm going to have negative 1 plus negative like 1.999. Oh, that's going to be negative 1 over positive 0. We're going to see us going towards negative infinity. This guy here, when it's negative 1 over x plus 2, that's going to be a little bit under 2, or a little bit over negative 2, or a little bit to the left of it, so like negative 2.1. So we get negative 1 over negative 0, quote unquote. That'll go towards positive infinity. Okay. Now the last thing I do, so what that means is I have a vertical asymptote at x equals negative 2. Now if I had checked these, okay, if I checked these, I have negative 1 over x plus 2, negative 1 over x plus 2 is what I'm really looking for because this guy's going to give me undefined. Negative 1 over really 3 is going to be negative 1/3. Negative 1 over again 3 will be negative 1/3. So this side also know that, oh wait, this isn't a vertical asymptote. It's just a point discontinuity because they both have a limit they approach of negative 1/3. Okay. Now the last thing I have to look at is what happens as x approaches positive infinity and what happens as x approaches negative infinity. Now the reason I don't have to, I actually have to check it this time versus the last problem is that I'm actually going to be able to include infinity as part of my domain. The last one I couldn't. So 1 minus x over x squared plus x minus 2. Well, we talked about this in class that, oh, since it's polynomial and the powers on the top and the bottom, and this guy's got a less degree than this one, I'm going to go towards 0. Same thing for this. So we have a horizontal asymptote of x equals 0. Okay. So let's take a look at this graph then and see how that all kind of shakes out. So we have 1 minus x, 1 minus x divided by x squared plus x minus 2. And as you can see, when I get rid of this guy here because he's not there, the graph has that from the left, okay, from the left, okay, it goes towards positive infinity. From the right, it goes towards negative infinity. Okay, from the left, positive infinity, right, negative infinity. As we go towards positive infinity, it goes to 0. So we go towards negative infinity, it goes to 0. So I have my horizontal asymptote of y equals 0. And I don't have at positive 1 an asymptote like we thought we would because it's just a point discontinuity. And over here, it'll tell me when I try to do f of 1, it'll say undefined. F of 1. It's undefined. It tried to plot the point, but it couldn't. Okay. So yeah, that's what ended up happening to this graph here. Okay. Now the last thing I want to look at, and I forgot to print this one off, is number, let's go here, number 30. Okay. Y equals x squared plus 1 over x minus 2. Okay. The directions say determine all vertical and slant asymptotes. So this one here is not going to have a horizontal asymptote. Okay, it'll go towards positive and negative infinity when I try to level it off. Now its vertical asymptote will be something like x equals 2 because of the fact that that's where this is 0 on the denominator. So I got to check the limit as x approaches 2 from the right and the limit as x approaches 2 from the left of x squared plus 1 over x minus 2. X squared plus 1 over x minus 2. Again, when I plug in 2 for the top, I'm going to get like 5 for both of them because again, it's continuous and it'll approach 5 from both sides. But here, when I go a little bit bigger than 2, I'm going to have positive 0, which means we're going to go towards positive infinity. On this one here, I'm going to have just a little bit under 2, so it'll be negative 0, quote unquote negative 0. So I'll go towards negative infinity. So yes, vertical asymptote, x equals 2. Now, if I try to do my horizontal asymptote, I'll just do it as one side. We can look at the powers and compare that real quick and say, oh, the power on top's bigger, so it's going to grow faster. Or if we divide everything by x, which is our trick, we get limit as x approaches infinity of x plus 1 over x over 1 minus 2 over x. So that's going to give me infinity plus 0 over 1 minus 0, which is infinity over 1, which is infinity. Same thing happens with negative infinity, and what happens is it goes downward. So there are no horizontal asymptotes because it never levels off. So it means there's a slant asymptote, which in order to figure out what that equation is, I have to do long division. So x squared, I can go into x times, so x squared minus 2x. Switch the sign. 2x plus 1 plus 2. That ends up being then 2x minus 4, which switch the signs plus 5. So plus 5 over x minus 2. Well, this is going to level off towards 0. So my slant asymptote is y equals x plus 2. Okay. And let's take a look at that graph. X squared plus 1 divided by x minus 2. So vertical asymptote is x equals 2. There. Slant asymptote, y equals x plus 2. And if I zoom out of the graph, you can see that it's following that slant asymptote and following the vertical asymptote. Okay. So the key to this section really is the fact that you found asymptotes before. You did this all in Algebra 1 and Algebra 2 and pre-calculus, but we always had to kind of talk around them and how they worked. Now we have really a formal process to find any kind of asymptote using limits. So if that doesn't make sense, come on in. I'll walk you through and help you out. But otherwise, yeah, good luck.